All right, folks. Yesterday, we started talking about simplifying radicals. And specifically right now, we are simplifying square roots. So we talked yesterday about how to simplify things like the square root of 80. Remember that a square root is the opposite of squaring a number. So if I ask you for the square root of 80, I'm asking you what number times itself will give me 80 as the answer. And we know that 80 is not a perfect square, so there is no number that will do that. So to simplify, what we did is we took the square root of 80 and we factored it. And we factored it in such a way that one of our numbers is a perfect square and the other number is not. So one of the numbers that you use to factor the square root of 80 has to be a perfect square. So here's what we did. We made a list of the perfect squares from 1 squared all the way up to 26 squared. So I'm trying to simplify the square root of 80. Well, the square root of 80 would fall between 64 and 81. So what I would do is start here at 64, and I would try to find the perfect square in this part of the list right here that can be used to factor that 80. And remember, we want to get the biggest perfect square. So I know 80 won't divide by 64, it won't divide by 49, it won't divide by 36, it won't divide by 25. 80, though, will divide by 16. If I do 80 divided by 16, I get 5. So 16 is the perfect square that I'm going to use to help me factor this square root of 80. So I'm going to rewrite this as the square root of 16 times the square root of 5. Now, square root of 16 means what number times itself is 16. That, of course, is 4. The square root of 5 means what number times itself is 5. And there is no answer for that, so I'll leave that part alone. So the square root of 80 in simplest form would be 4 root 5, or 4 square roots of 5, or 4 times the square root of 5. All of those would be valid ways to read that answer. So that's how we simplify the square root of a number. We factor the perfect square into 2 square roots so that one of them is a perfect square. Now, what we're going to do today is we're going to add variables to this. So we're going to simplify square roots with variables. All right, so here's the way we'll get started. Let's start with the square root of x to the first power. That means what number or what can I multiply times itself and get x as the answer? There's nothing that will do that. So this is a square root that I wouldn't be able to do. So now let's do the square root of x squared. That means what would I multiply times itself in order to get x squared? We can do that because we know that to get x squared, we could multiply x times itself. So the square root of x squared would be x because x times x is equal to x squared. So that one we can do. All right, square root of x to the third. What can I multiply times itself to get x to the third power? The answer is there's nothing that I can multiply times itself to get x to the third power, so I can't do that one. All right, so let's go to the square root of x to the fourth power. What can I multiply times itself that will get me x to the fourth power? Well, this I can do. The answer would be x squared And that's because x squared times itself would equal x to the 4th power. So this one I can do. The square root of x to the 5th power. What can I multiply times itself to get x to the 5th power? There's nothing. I could do x to the 1st times x to the 4th. I could do x to the 2nd times x to the 3rd, but there is nothing I can multiply times itself and get x to the 5th power. All right, square root of x to the 6th. What could you multiply times itself to get x to the 6th? The answer is x to the 3rd. X to the 3rd times x to the 3rd equals x to the 6th. So that one we can do. Square root of x to the 7th. What can I multiply times itself to get x to the 7th? There is nothing. I could do x to the 1st times x to the 6th, x to the 2nd times x to the 5th, x to the 3rd times x to the 4th, but there is nothing I can multiply times itself to get that. So I hope what you're seeing here is a pattern to things. Look at the odd powers of x. We had x to the 1st, 3rd, 5th, 7th. The odd ones we couldn't do, but all of the even ones we can. We could take the square root of x squared, the square root of x to the 4th, the square root of x to the 6th, and I want you to notice what happens. To take the square root, what we actually do is cut this exponent in half. So the 2 became a 1. Half of 2 is 1. The 4 became a 2. Half of 4 is 2. The 6 became a 3. Half of 6 is 3. So notice that you can take the square root of even exponents, and that what happens is you split that exponent in half. So what that should mean is I should be able to do the square root of x to the 8th. And the answer, the exponent should be half of what it is right now. So that should be x to the 4th. If I try to do x to the 9th, can't do that. Okay, if I try to do x to the 10th, I can do that. Half of 10 is 5, so that should be x to the 5th. Now, it doesn't mean that these odd ones can't be done. It just means that we're going to have to do something similar to what we did yesterday. So now let's look at that. Here is one of the ones that we were not able to do over there. I can't find anything that I can multiply times itself and get x to the 3rd as the result. So again here, what you're going to do is simplify this in much the same way that you did your numbers yesterday. You're going to split this up into 2 square roots. So you're going to factor it. And you're going to factor it so that one of these is a perfect square. So I want you to think about this. X to the 3rd. I could rewrite that as the square root of x squared times the square root of x to the 1st. This one I can do, this one I can't do. So it's just like what you did yesterday. So the square root of x squared, what can I multiply times itself to get x squared? The answer is x. For the square root of x, what can I multiply times itself to get x? Can't do that, so I leave it alone. So this is going to become x times the square root of x. So there's the simplified version. If I wanted to do the square root of x to the 5th, I can't find anything that I can multiply times itself to get x to the 5th, so what I'll do is factor it. I'll factor it so that one of the factors is a perfect square. So for x to the 5th, we could do x to the 4th times x to the 1st. What would you multiply times itself to get x to the 4th? X squared. Can't do the square root of x, so it stays the same. So this would be x to the 2nd power times the square root of x. Let's do the square root of x to the 7th power. We're going to factor it so that one of the factors is a perfect square. So we could do x to the 6th times x to the 1st. Square root of x to the 6th is going to be x to the 3rd. The square root of x we can't do, so it stays the same. And let's do one more. Let's do the square root of x to the 9th. We're going to factor that so that one of them is a perfect square. So I think the best way to do this would be x to the 8th times x to the 1st. When we take the square root of x to the 8th, we get x to the 4th times the square root of x. So notice what we're doing here. We're taking x to the 3rd and splitting it up so that one of the factors is a perfect square and the other is not. So it's just like what we did yesterday. All right, so let's put this all together now. So in these problems, you're going to have to use some of what you learned yesterday with what we're talking about today. So we are going to simplify the square root of 98 x to the 7th power. To do that, we are going to factor it so that we have perfect squares in one square root and non-perfect squares in the other. So you'll remember how I talked about we'll have a square root that we can do and a square root that we can't do. So here's what we're going to do first. First, we're going to deal with the 98. Now, to simplify the square root of 98, that's where we need to go to our list. All right, 98 would fall between 81 and 100. So what I'll do is start here at 81, and I'll work my way up through the perfect squares until I find the biggest one that is a factor of 98. So 98 will not divide by 81. It won't divide by 64, but 98 will divide by 49. 98 divided by 49 is 2. So I'm going to use 49 times 2 to factor the square root of 98. So I'm going to come in here and I'm going to do the square root of 49 times the square root of 2 for my 98. So notice that that comes from the list. Now, I'm going to look at my x to the 7th. In order to be able to take the square root, I need an exponent that is even. Well, the biggest even exponent that I can get out of x to the 7th is x to the 6th. It's the biggest even exponent I can get out of that number. So I'm going to take my x to the 7th and I'm going to factor it as x to the 6th times x to the 1st. So over here I have my perfect squares. These are the things I can do. And then over here I have put my non-perfect squares. Those are the things that I can't do. All right, so notice we use the list for the coefficient, and then we're looking for the biggest even power that we can get out of our exponent when we do that part. All right, so here we go. The square root of 49 should be 7 because it takes 7 times 7 to make 49. The square root of x to the 6th should be x to the 3rd. Remember, we cut the exponent in half. It takes x to the 3rd times x to the 3rd to make that x to the 6th. So from this square root, we get 7x to the 3rd. That's the first part of my answer. Now, this stuff over here, I can't take the square root of. I can't do it. So I'm going to go ahead and leave that part alone. So when I'm all done, the simplified answer for the square root of 98x to the 7th is 7x to the 3rd times the square root of 2x. So notice this part that I'm unable to do, I just leave alone. So there's our first example. So take one thing at a time. All right, let's try another one. Let's try the square root of 25 x to the 5th, y to the 9th. Now again, to simplify this, we're going to factor it. And when we factor it, we're going to put perfect squares in our first square root and non-perfect squares in our second square root. So we'll start out with our coefficient, which is 25. Now, if I go back and I look at my perfect squares list, what I'll notice is 25 is in there. So he is already a perfect square. He is good to go. So I'm not going to have to break down that 25. I'm going to go ahead and put him in my perfect squares square root. And the first one, the one I'm going to be able to do, because it already is a perfect square. All right, now I'm going to deal with my variables. I've got x to the 5th power. Now remember, to be able to take the square root of a variable, it has to have an even exponent. So the biggest even exponent that I can get out of x to the 5th is x to the 4th. So it would take x to the 4th times x to the 1st to get me that x to the 5th. So I'm splitting it up, I'm factoring it so that part of it is a perfect square and the other part is not. All right, now finally, I've got my y to the 9th. Now remember, to take the square root of y to the 9th, I need the exponent to be even, and it is not. So what I want to do is get the biggest even number out of that 9 that I can. The biggest even number I can get out of 9 is an 8. So I'm going to factor y to the 9th into y to the 8th times y to the 1st. So notice, the first part needs to be the biggest perfect square you can get. The second part will not be a perfect square. All right, so now that we've got it factored, now we can actually simplify this first root. The square root of 25 we know is 5, because 5 times 5 is 25. The square root of x to the 4th will cut the exponent in half and give us x squared. X squared times x squared is x to the 4th. For the square root of y to the 8th, again, cut the exponent in half. That'll be y to the 4th. Y to the 4th times y to the 4th is y to the 8th. And then this is the stuff over here that I am not able to do. So I just bring down that square root into my answer. So here is my simplified version of this radical. 5x squared y to the 4th times the square root of xy. So I want you to notice how I'm just taking one piece of the puzzle at a time as I factor the coefficient and then each variable. All right. And notice again how we factor it into two radicals, one that we can do, that is a perfect square, and one that we can't do. Okay, so on this one, no coefficients, just variables. All right, so I won't need my list this time. I'm going to start out with x to the 5th. To take the square root, I need an exponent that is even. 5 is not even. The biggest even number that I could get out of x to the 5th is x to the 4th. So I'm going to factor my x to the 5th into x to the 4th times x. Here's what I can do. Here's what I can't do. All right, so next up, y to the 9th, again, not an even exponent. The biggest even exponent that I could get out of 9 is an 8. So I'm going to factor y to the 9th into y to the 8th times y to the 1st. And then the last thing I have is z to the 1st. Not an even exponent. And what I want you to notice is we can't get an even exponent out of that. My exponent here is a 1. I can't get an even number out of that. So I'm going to put my z to the 1st over here. He is not a perfect square, and I can't get a perfect square out of him. So he is going to be in my can't do column. All right, so now that we've got it factored, now we're ready to simplify. For the square root of x to the 4th, split the exponent in half, and you're going to get x squared. For the square root of y to the 8th, split the exponent in half. That's going to become y to the 4th. x squared times x squared is x to the fourth. Y to the fourth times y to the fourth is y to the eighth. The other radical is the part that I knew I wouldn't be able to simplify, so I just pull that down into my answer. So here is my simplified answer. So notice for the ones that I could, for the 5, I got the biggest even number that I could get, which is a 4 out of that. For the 9, I got the biggest even number I could get, which was the 8. For the z to the first, I can't get an even number out of that, so that just goes over here in my non-perfect square radical. He can't be simplified, so I just leave him alone. All right, let's do the square root of 32p to the 7th, q to the 4th, r to the 16th. To simplify that, we're going to factor it into 2 square roots. Perfect squares are going to go in here, non-perfect squares over here. All right, so first, what we'll want to do is we'll want to go to our list and find the biggest perfect square that 32 will divide by. All right, so 32 would fall between 25 and 36. So starting at 25, I want to find the biggest perfect square in this part of the list that my 32 will divide by. 32 will not divide by 25. 32 will divide by 16. So I'm going to use 16 to help me factor that 32. All right, so for 32, I'm going to do 16 times 2. All right, now variables, we're going to take one at a time. P to the 7th. Remember, we need an even exponent. So I'm going to get the biggest even exponent that I can get out of the 7th power. So the biggest even number I could get out of that would be a 6. So it'll take p to the 6th times p to the 1st to keep me at p to the 7th. All right, now I'll move on to q to the 4th. Notice he already has an even exponent. So that means he can already be done. So I'm just going to go ahead and put him in that first radical where my perfect squares live. And then I have r to the 16th. Exponent here is already even as well. So I'm going to put that in that first radical as well. So for 32, I went to my list and I found the biggest perfect square that 32 would divide by. And then I went through here, and for 7, I got my biggest even exponent, which would be 6. For 4 and 16, they were already even, so I left them alone. All right, so now let's do this. The square root of 16 we know is 4. And then for these exponents, when I take the square root, I'm going to cut all of them in half. So I'm going to have p to the 3rd, I'm going to have q to the 2nd, and I'm going to have r to the 8th. 4 times 4 is 16. P to the 3rd times p to the 3rd is p to the 6th. Q to the 2nd times q to the 2nd is q to the 4th. And r to the 8th times r to the 8th is r to the 16th. That second radical has my non-perfect squares that I can't do. So I know that part is just going to stay the same. Okay, for these last 2 problems I want to do with you, we're going to bring in one more element here. And we saw this the other day, so this shouldn't be too big a deal. I'm going to go ahead and put a number outside of this square root. And we're going to simplify 2 square roots of 50 a to the 16th b. Now, when you go to factor this, remember that this is 2 times the square root of 50 a to the 16th b. And then what we've got to do is take that square root and factor it. So what I want you to notice is this 2, again, is just going to hang out here and wait until we factor this square root and get him simplified. So we'll start with our 50. You'll go to your perfect squares list and find the biggest perfect square that is a factor. That should be 25. So for 50, we're going to do 25 times 2. When we go to our A, notice he already has an even exponent, so that means he is a perfect square. So I'm going to put him in here with 25. And then when I go to my B, notice that his exponent is a 1, not even, and I can't even get an even exponent out of that. So that means the B will go over here with the 2. He is not a perfect square, and I can't factor him so that I get a perfect square. So to kind of recap what we just did there, 50 is 25 times 2. The 25 comes from the list. 8 to the 16th, already a perfect square because of the even exponent, so we put it with the 25. B to the first, not an even exponent, and I can't get an even exponent from it, so he goes over here with the 2. All right, so what will happen now is 2 will move down to the next line, and we will take this square root. The square root of 25 is 5. The square root of 8 to the 16th, that exponent will get cut in half and become 8 to the 8th. So 5 times 5 is 25, 8 to the 8th times 8 to the 8th is 8 to the 16th. This square root is the one we knew we couldn't do, so we leave him alone. Now there's one more thing you can do here. You've got 2 times 5a to the 8th. You can multiply these together. So 2 times 5 will be 10, a to the 8th, and then that will be times the square root of 2b. So there is your simplified answer. All right, one last one. Let's do -3 times the square root of 200 x to the 10th y to the 7th. All right, so right off the bat, we know we have -3 times the square root of 200 x to the 10th y to the 7th. Now this square root we know is going to have to be factored. We're going to factor it into 2 square roots, one of them containing perfect squares and one of them non-perfect squares. So we'll start with our 200. This is where we'll go to the list and find the biggest perfect square in that list that is a factor of 200. 100 would be the biggest perfect square I could think of. So we're going to make that 200 100 times 2. This is a perfect square. This is not. All right, on to the variables. X to the 10th has an even exponent. So he is a perfect square already. So you'll put him with the 100. And then finally, our y to the 7th, not a perfect square because this is not even. Get the biggest even number you can from that exponent. The biggest even number you could get would be a 6. So for y to the 7th, we're going to put y to the 6th in here. And then we would need y to the 1st in here so that we still have y to the 7th. All right, -3 is going to hang around while we take this square root. The square root of 100 is 10. And then we'll cut both of these exponents in half. So it'll be x to the 5th, y to the 3rd. And then we have times the square root of 2y. We can multiply -3 times 10 and get -30, x to the 5th, y to the 3rd, and then that will be times the square root of 2y. So notice again, we are factoring into 2 square roots. We want perfect squares over here and non-perfect squares over here. The coefficients, you're still using that list. And then as far as variables are concerned, perfect squares are going to have even exponents. Non-perfect squares are going to have odd exponents. And if you happen to run across an odd exponent like we did here with y to the 7th, then get the biggest even number out of that you can. So y to the 6th would go in the perfect squares column, and then that leftover y to the 1st would go in the non-perfect squares column. I think you have 10 problems like this to try today. If you have any questions at all, I will be checking my email throughout the day, so let me know. You all have a happy Thanksgiving. Enjoy the time with your families, relax, and just have a wonderful holiday.